Welcome back everyone, it's another day and let's get started. Last time we covered a couple key things about some variables. How to name them, how to declare them, and how to assign to them. And then we gave you some assignments to work on. Now, throughout that assignment, you might have had some questions. So in this video, we're going to alleviate some of those concerns by answering some of the most common questions that we would expect you to naturally come to in that assignment. Then we'll go over one of the best tools you'll be using to help manage your variables. And lastly, we're going to talk about something called user input. The first thing you might have noticed when you went ahead and did your assignment was perhaps when you were dividing 1 by 5, you got 0. That's because, remember, integers are only whole numbers. When you told the computer you wanted the number 1, it was assuming that number 1 is an integer. And then when you divided integer 1 by integer 5, you would get 0.2, but because integers always drop all the decimal points, you would get just 0. Now this is very important because if you wanted to preserve the decimal points, you somehow have to indicate to the computer, hey, I don't want an integer, what I do want is a floating point number. So there you would type in 1.0 divided by 5. And what does that tell the computer? That tells it I want you to divide decimal 1 by a whole number 5. And whenever you divide a decimal by a whole number, you will get a decimal out. So if you divide a whole number by a whole number, you'll get a whole number out. But if you divide a decimal by a whole number, or inversely a whole number by a decimal, you will always get a decimal out. So the thing you need to remember when you're doing this is if you want a decimal, just remember you have to somehow tell the computer these numbers are decimals, not whole numbers. And if you encountered any more issues, go ahead and send us a note in the Slack channel or leave a comment below, and we'll go ahead and either address them in the next video or we'll make a follow-up video just answering all the questions regarding lesson 1. Well, let's jump to the next concept that we'll be discussing, the tools. And the tool we'll be using the most is the memory table. Now, what is a memory table? Let's just do a really quick review about what a variable is. When we were declaring variables last time, we had to do the following. We would say, first we'd give the type, then we'd write the name of the variable, then we'd say what it equals and say that it equals some value. And of course we'd end that with a semicolon. Once we went ahead and did this, we could use this name to reference this value throughout the program. If we went ahead and wanted another variable, we'd simply redeclare a new type again and call a unique name and then say give it another value. And of course, just like before, we could use this second name to indicate this value. Now, right now, our programs are actually quite small. So as our programs don't get larger and larger in size, it's going to be okay. But as we would expect, throughout your growth, we're going to expect you to write larger and larger programs. Even experienced programmers are not able to keep track of everything in their head. To help you build the right muscles, we're going to train you to use some tools that are later going to build into the most natural tools that you're going to use in any software industry job. And that tool is going to be the memory table. Now, just like these variables have types, names, and values, your memory table is going to have something very, very similar. You're going to write a table that has 3 columns. I like to leave the middle one slightly bigger. You're going to write the type in this table. You're going to write the name of the variable in this column, and then you'll write the value of that variable. So let's go ahead and quickly do an example of what we mean by this. Right over here, I've got some code ready for you, and I've got my memory table on the side. I'm going to go ahead and replace this with some of our sample code. Now, some of you may recognize this code as it's from lesson 1. If not, make sure you go ahead and do this assignment before you come back to this video. So what does it mean to use a memory table for this assignment? If we're going to build out this memory table, the number one thing we'll notice is, as before, we're going to go to the beginning of our main, and once we're here, we're going to start going down the lines one by one. Now, this line is a comment. Because this line is a comment, we know the computer isn't going to interpret it. Our memory table tool is also not going to interpret it. So let's go ahead and jump over to line 5. Line 5 tells us we're adding a new variable for the first time, and its type is an integer, its name is number of avocados, and its value is 3. How do we know that we're adding a new variable? Because we've defined it here. If we didn't include the type, it wouldn't be considered a definition. So whenever we're doing something on a line that defines a new variable, what that means is we need to add a new column into our memory table. How are we going to represent this in our memory table? Any ideas? Well, the first thing we're going to do is we're going to write the type of that variable in the type column. Then we're going to write the name of that variable in the name column. And lastly, we'll write the value of that variable in the value column. Then we'll go on to line number 6. Line number 6 tells us, once again, we're adding a new variable. This time, the type of that variable is a float. The name of that variable is number of onions. And the value of that variable is a 0.5. Line number 7 is very similar. Type of this variable is an integer. The name of this variable is number of tomatoes. And the value of this variable is a 1. Line number 9 asks us to enter the type as a float. The value of the variable is price per avocado. And the value of this variable is going to be 5.0 divided by 7. But because I've put a point in there, it's going to be a fractional output rather than the whole output, which would be 0 in this case. So the fractional output is going to be something along the lines of 0.714 and so on and so on. I'm not going to write the entire value. Remember, it's key in your memory tables that you always write out the decimal value, because otherwise you might make a mistake with types. So if you know that your left-hand column is going to be a float, then the number one thing you can identify is that you're allowed to have decimal points here. If this number was an integer instead of a float, I would be left only with 0 in this value. However, because it's a float, I'm allowed to have the whole thing present. Line 10 asks me to another variable, which is going to be another float, price per onion. And the price per onion is going to be 0.75 exactly. And on line 11, we have another float, and that is going to be named price per tomato. And that is going to be of the value 1.0 divided by 2, so that is going to be 0.5. And then on line 13, we're actually going to finally get to use our memory table and check if we have any issues. So the first thing we do in our memory table is going to start from the very left-hand side, and that says, make a new variable of type float, name that variable price per pint, and the value of this variable is actually going to be an expression that we have to compute. And the way we're going to compute expressions is we're going to leverage our memory table to tell us what we need to do. I'm going to use my scratchpad on the bottom of the screen to keep track of everything. So the first thing it tells me to do is find the variable called number of avocados. So I'm going to go ahead and do that, and I'm going to highlight the value and the name of this variable. And that gives me a 3. So I'll plug in 3 for that number. Then it says multiply that by the price per avocado variable. So I'm going to go ahead and once again highlight this and put this in here. And I'm going to plug in the value here, which is going to be 0.714, so on and so on. And then it says add that to the number of onions variable, which comes up from here. And I'm going to add a 0.5, which I'm then going to multiply by the price per onion variable. I'm going to plug that in, and then I will be adding that with the number of tomatoes variable, and I'll be multiplying that by the price per tomato variable. And if I were to do that, my answer would end up being the value 3.017, and so on and so on. Now, once I've computed my value, I can simply just go ahead and plug that into the value of my new variable price per pint. So that is going to be 3.017, and so on and so on. So now my memory table should just look like this, where I've used all the variables in the past to compute my new value for this new variable that I've just declared in this statement. Now, line 15 does something very similar to what we just did before, just a little bit easier to understand. Line 15 asks me to define a new variable that is of type float, name it price per quart, and its value is going to be just double the value of the price per pint variable. So if we were to go do this, it's asking us to find the price per pint variable. So I'm going to write that over here, 3.017, and so on and so on. Multiply this by 2, and this is going to end up equaling 6.0 3, 5, and so on and so on. And plug in that value into the new price per quart variable. 3, 5, so on and so on. Line 16, we ask ourselves, are we adding any new variables? The answer is no, because we're not giving any type specifiers, so we know for sure we won't be adding more columns into our memory table. We ask ourselves, are we using any variables? The answer is yes, so we're going to go ahead and find the variable we're using, which is the price per quart variable. And we're going to give that to the cout, or the console output command, which is going to end up printing it out in the terminal. Then we'll move on to line 17. It's going to define a new variable of type float. We're going to name it price per gallon, and we're going to set the value equal to the price per quart variable multiplied by 4. So this is going to equal 24.1 something. And let's go ahead and set that to the value of our price per gallon variable. And then on line 18, we're going to ask ourselves once again, are we adding any columns to our memory table? Again, the answer is no, because there's no type specified in this line indicating we're creating a new variable. Are we using a variable? The answer is yes. It's saying to use the price per gallon variable. And then we're simply going to take this value and give it to cout to print out. So throughout this program, we are expecting it to have built this memory table. And lastly, we're expecting it to have printed out these two values along with these two statements over here. Let's go ahead and confirm this by trying to hit the run button. And just like we expect, we got 6.035 in the price per quart variable with a 7.1 that I did not write down. For the price per gallon, we ended up computing exactly $24.1429. Now this might seem like a very basic example, but there's a couple key things that we learned from this. One, no matter what line of code we're on, we can only use the variables that are already in our memory table. If we try and use a variable that doesn't exist in our memory table, just like we won't be able to know what the value of that variable is, the computer can't know either. Because just like you're building a memory table, the computer is building something very, very similar. So the muscle we're practicing here is learning to think exactly like the computer is thinking while it's running through your code. You need to go ahead and define it for your program to understand exactly what you mean by that variable. Now another thing we have learned, imagine that we allowed ourselves to have another variable in here called int number of avocados. And let's say this value was 15. If we are ever to search our memory table for the value of the variable named number of avocados, we would find two results. Not only would we find two results, we would have no idea which is the one we meant. So just like you would be confused looking at your memory table about which number of avocados do I mean, the computer is going to be just as confused. You are not allowed to use the same variable name again because it wouldn't make sense in the context of searching for which value you want when you're using that variable name. So just like you wouldn't know what you're doing in your memory table, the computer was not going to know about its own memory table either. But to reiterate on this and do a slightly more challenging example, let's try something out. Now this example is going to build off of what we did last time in the video. So just like always, we're going to start our memory table with 3 columns. The 3 columns are going to be a type, a name, and a value. And we're going to go to the top of our code, which starts always at main, and we're going to go on to the next line right after it. The next line asks us the following. Declare a new variable of type int. Its name is going to be car cost. Its value is going to be 15,000. Then we move on to the next line. The next line is going to indicate to us int. The variable name is going to be called engine upgrade. And the value of this variable is going to be 500. On line 7, we again ask ourselves, are we creating a new variable? The answer is no. Are we using a variable? The answer is yes. We're going to be using the car cost variable, and we're going to be printing out its value. On line 8, we're going to do something very similar, which is, we're going to ask ourselves, are we using any variables? The answer is yes. We're going to be using this one, and we're going to be printing out its value using cout. On line 10, we ask ourselves, are we creating a new variable? The answer here is no, because once again, we are not using a type specifier indicating that we have to create a new column in our memory table. Are we using a variable? In fact, we are. We're using two variables. We're using this one, car cost, and lastly, we're using engine upgrade. So let's go ahead and look at the right-hand side. The right-hand side is saying, grab me the value of those two variables. So let's go ahead and write them down. They're going to be 15,000 plus the value of the engine upgrade variable, which is 500. And if we add them up together, we should get $15,500. And now the left-hand side is saying this is the variable that should have that value. So of course, we're going to change the value of this variable. We're going to just erase the old value and update it to be 15,500. Now this is different than creating a new variable because what I'm doing is I'm modifying an existing variable and changing its value to be 15,500 in this case. So in my memory tables, when I'm ever modifying something, I like to just cross out the value and just leave the new value on the right-hand side of it. The reason is this lets me remember if I ever refer back to my memory table that I actually changed this variable's value. Now some of you might choose to erase it, and that's totally acceptable. I personally choose to cross it out so it's abundantly clear what I did throughout my program was I did modify this variable's value. On line 11, we're going to ask ourselves, are we creating a new variable? The answer is no. And then we're going to ask ourselves, are we using a variable? The answer is yes. We're using the car cost variable, and we're going to print out its value. And now the value of our car cost variable, according to our memory table, is 15,500. So we should expect that this code is going to print out the following. It's going to print out the car cost variable originally, which at that time was 15,000. Then it's going to print out the engine cost variable, which is 500. And lastly, it's going to print out the car cost variable again, which later was 15,500. So let's go ahead and run this program to make sure it does what we expect. And there you have it, everyone. We can see that it printed out exactly 15,500 and lastly 15,500. Now once again, these programs may seem very basic, but it's very important that I reiterate to you that if you're able to build a muscle memory for how to write down memory tables, when we get to the more complicated programs, your life is going to be immensely easier. Now, some of you may also struggle with memory tables, and that's okay. All you need to do if you ever mess up, no matter how annoying it is just start from the beginning of your program and work your way down again. The thing about memory tables is that they're sequential. You can't just jump to line 10 and start solving it right away because you need to know everything that happened in your program up until line 10. So if you do mess up in your memory table, 1, start over again. 2, no matter how annoying it is, always do the memory table, even if you think your code is absolutely correct. Because when it's not, you will not have built that muscle that lets you write down memory tables quickly and efficiently. Well, that's it with memory tables, everyone. It's finally time to move on to the next aspect that's going to start making your code much more interesting. You may have felt that your code is really just doing one thing at a time and it doesn't feel very dynamic. You might be asking, why can't I just do this on a calculator? Or perhaps pen and paper is easier and faster. One of the nicest things about programming is the ability to be very general. For example, Facebook doesn't end up writing a different piece of software for my profile page and your profile page. It's all the same software, but somehow Facebook tells that software, in this case refer to me, but in your case refer to you. That's because, once again, code is meant to be very, very general. We're going to get our first taste of how to write generalized software by a concept called user input. What do I mean by user input? By user input, I mean the idea is your code will be asking the user or prompting the user to give a reply. Not only will it be prompting the user to give a reply, it will actually wait until the user indicates some sort of a response. So for example, if I were to ask you, how much does your car cost? If you don't reply, I might prompt you and ask again. But in the computer's case, if it's going to ask you how much does your car cost, the program will simply just wait there until the user finally says the value of their car cost. Let's go ahead and kind of replicate what we mean by this. So the first thing I'd like to do over here is I'd like to std out how much does your car cost. So again, this code is going to be exactly the same as last time, but if I hit the run button, I will see a question pop up, how much does your car cost? Now, just because I put a question here does not mean that the computer knows what I want to do. What I need to do over here is use a specific type of input called stdcin. Stdcin, as you might guess, is just the opposite of stdcout. Stdcout takes data from here and sends it to the console. Stdcin takes data from the console and sends it to whatever variable you want it to send it to. For example, if I wanted to get an integer from a user, stdcin here is saying, wait until I get an integer from a user and send it to the car cost variable. So what does this mean? Let's try and run our code and see what happens. It's paused. And just like I said before, your computer is going to wait indefinitely until you finally give it an answer. So let's say I tell it my car costs $1,000. And I haven't told the computer I'm done with my answer because I could keep on typing more and more. So I have to say I'm done by hitting the enter key. So once I've said it costs $1,000, you might notice that it prints out my car's cost is $1,000, the engine upgrade is $500, and the new car cost is $1,500. So let's go ahead and try and reason throughout this code and figure out what it's doing exactly. To start off with, let's go ahead and write our memory table. Our memory table starts off with the type column. It then has the name column. And lastly, it has the value column. And we're going to go off to the beginning of our code at main, and we're going to go to the next line. On this line, we ask ourselves, are we creating any new variables? The answer is no. Are we using any variables? The answer is no. So we're going to move on to the next line as it doesn't affect our memory table. Line 6, are we creating any new variables? The answer is yes. We're creating a variable of type int. The name is car cost, and the value is 15,000. Then we're going to go on to the next line, and we're going to ask ourselves, are we creating a new variable? The answer is yes. We're creating a variable called int engine upgrade. Fill out its value as 500. The next line is our new line where we're doing stdcin into the variable car cost. So we ask ourselves, 1, are we creating any new variables? The answer is no. Are we using any variables? The answer is yes. And just like cout would print out this value, cin is going to get a value from the terminal. Now let's imagine that in terminal I typed in the value $19,289. What that means is cin is going to send that value, and that's why these arrows are the opposite direction, into the variable named car cost. So when it sends the value over into that variable, it's simply going to cross out the old value and upgrade it to the new value of $19,289. And we'll move on with our code from here. Line 11, we ask ourselves, are we creating a new variable? The answer is no. Are we using a variable? The answer is yes. We're using the car cost variable. And when we use the car cost variable, we're going to print out its value, which is 19,289. And then we ask ourselves, are we using a variable on this line? The answer is yes, we are. We're using the engine upgrade variable. And we're going to print out the 500 value in this case. And on line 14, just like before, we ask ourselves, are we using any variables? Yes, we're using the car cost variable and the engine upgrade variable. And because the left and right side are both using variables, we're going to go ahead and do the right side first. The right side says grab the values of both of these variables. So let's go ahead and do that. 19,289 plus the value of the variable engine upgrade, which is going to be 500. And that is going to equal 19,789. And we want to set that as the value of the car cost variable. And once we're done with that line, our memory table should look like this. Now line 15 says, are we using any variables? The answer is yes. We're using the car cost variable. And we're simply going to print out its value, and its value is now 19,789. So throughout this, we're expecting it to print out this value, and this value as outlined by this line, and this line, and this line. Let's go ahead and run the run button. Now, just like last time, it doesn't actually know what my input is. So let me go ahead and type in my input that we talked about, 19,289. And of course, I'm going to hit the enter button. And just like expected, we got 19,289, 500, and 19,789. Now, I'm going to leave the reference code for you guys so you're able to refer back to it. But we have some really exciting exercises for you. One, we've got a bunch of sample code that I'd like you to walk through and write memory tables for. Two, I'd like you to walk back on your code that you wrote in lesson 1 and write memory tables for all of that. And lastly, our new exciting exercise is we're going to be writing a calculator. Remember, don't give up. C++ is hard, programming is hard, but that doesn't mean it won't be worth it. All you have to do is take it forward one line at a time. Until next time, goodbye.